In India, so many companies are marketing and promoting their silicate-based product. Different people say different things. Here we will take insight of two products, colloidal silica hydroxle concrete densifier versus sodium silicate densifier. Some attempts to bring clarification about the products. Colloidal silica hydroxle is a mixture of a liquid and silica particles. It is a colloid, not a solution. In a solution, the solvent such as water breaks the active ingredient down to individual molecules. The silica particles in colloidal silica densifier are nanoscale in size. A colloidal silica densifier that is specially formulated for soft concrete features particles of about 40 to 45 nanometer. Colloidal silica hydroxle cannot be made simply by mixing silica into water such as sodium silicate. The high-tech industrial process begins by stripping sodium and a considerable portion of contaminants from sodium silicate and then suspending the purified silica in a low-surface tension liquid. The term colloidal silica hydroxle always refers to a liquid material. To understand in a better manner, a reaction mechanism of colloidal silica hydroxle and sodium silicate need to be considered. All concrete densifiers react with a useless calcium hydroxide and turn it into useful calcium silicate hydrate. Since calcium hydroxide is intermingled in the hardened cement paste, the reaction creates additional paste inside the pores of the existing paste. The paste gets denser, which makes it harder, but no reaction exhibits with unreacted fly ash present in the concrete with sodium silicate made with weak base raw material. Redond hard colloidal silica hydroxle react with unreacted fly ash present in the concrete. It dissolves the fly ash main constitutes silica and alumina present unreacted in the form of loose top wearing surface. This is the main reason why mostly laid factory, warehouse floors top surface eroded in an initial month of operational. Cement paste is not a crystal to begin with. Crystals are molecules stacked together in a regular, repeated pattern. In contrast, calcium silicate hydrate is technically a gel. The molecules are packed together and hard, but they do not form a regular, repeated pattern. The major differences of products comes from its particle size, absorption and sorptivity network made during reaction process. The goal of all concrete densifiers is to deliver a reactive form of silica down into the microscopic pore system of the cement paste. They all use as liquid to carry the silica. The differences are in the form of silica and how the silica is made to stay in the liquid. In sodium silicate, excess mixed water will evaporate from the surface and it will be unequally distributed densified. Colloidal silica delivers virtually pure silica in nanoparticles small enough to penetrate the pore structure. The liquid has very low surface tension and carries particles below the surface. The pure silica particles have a relatively higher proportion of reactive sites than silicates, so they react very efficiently. In the pores, colloidal silica creates new calcium silicate hydrate that bonds to the existing calcium silicate hydrate. Colloidal silica also bonds directly to other silica, including itself. When applied to concrete, it reacts, makes bond and then uses that bonded silica as a platform for additional bonding. Sodium silicate densifiers do not do this. It can be applied to build up on the surface. Redond hard colloidal silica hydroxle can be burnished to a high sheen in a way not possible with silicate densifiers. Performance would be an extra edge in colloidal silica hydroxle. More penetration to the concrete top surface, more reactivity and solid bond formation make a step ahead to sodium silicate. There are no real standards for densification. Owners, architects and ultimate user need to understand the difference between densification and polishing. Both are different and having variable characteristic. A good densified floor need not to be polished. Complete calculation of floor consumption will guide to owners, architects. However, properties such as abrasion resistance and surface hardness are considered indicators of densification. For taking performance from factory, warehouse floor you need to understand the concept, products reaction mechanism of colloidal silica hydroxle. Why and how it would be helpful to take superior performance from newly laid floor still you have used dry shake hardener. Dry shake hardener uses cannot guarantee superior performance from the floor because it is also a cementitious material and cannot blocks microcapillary system made during water evaporation, Low needle or surface vibrator use, void volume ratio. Your casted floor should not be liability for your factory in initial month of operation from the project handover date. So clear your doubt and take maximum performance from your factory, warehouse floor. This is your time to choose Redon Hard Colloidal Silica Hydroxle for your dream project. For more technical and commercial details, contact us.